Hello Prep 3. Today we will study the last lesson for this year, lesson 3 in geometry, in your booklet page 98. The corollaries of theorem 1 and its well-known problems. We studied in the previous two lessons the central angle and the measure of the arc, length of the arc, and the relation between the inscribed angle and the central angle, which are subtend the same arc. Today we'll study some corollaries on theorem 1. Corollary 1. The measure of an inscribed angle is half the measure of the subtended arc. We studied before that the measure of the arc is equal to the measure of the central angle which subtend this arc. And we studied also that the measure of the inscribed angle is half the measure of the central angle which subtend the same arc. So the central angle is equal to the measure of the arc, then the measure of the inscribed angle is half the measure of the subtended arc. So we can say that the measure of ACB equal half the measure of AMB, or we can say that the measure of the angle ACB half the measure of the arc AB. So measure of angle C equal half measure of the arc AB. Remark, the measure of the arc equals twice the measure of the inscribed angle subtended by the same or this arc. This is the first corollary. Number 2, the inscribed angle in a semicircle is a right angle. The inscribed angle ACB here drawn in a semicircle because AB is a diameter. So the measure of this angle will be 90 degrees because it will equal half the central angle here, and the central angle here is a straight central angle. Its measure is 180 degrees. So the measure of the angle C will be 90 degrees. So the inscribed angle in a semicircle is a right angle. So measure of angle C equal 90 degrees. Remarks. Number 1, the inscribed angle which is right angle, if the inscribed angle is right, so it's drawn in a semicircle. Okay? And if the measure of the arc less than the measure of the semicircle, so less than 180, so the inscribed angle which subtends this arc will be acute angle. And if the measure of the arc is greater than the measure of a semicircle or greater than 180, so the measure of the inscribed angle which subtends this arc will be obtuse angle. Okay, let's go to our first example in page 99. AB is a diameter in a circle M. AC touch it at A. Touch, the line touch the circle at one point. So this line we called it, yes, excellent, tangent. And A is called a point of tangency. And we have a right angle at this point with the diameter. BC is intersected at D. If BD equal 9.6, DC equal 5.4, find the length of the radius of the circle M. Radius of the circle MA or MB. First, I have a diameter. So we have a semicircle. And we have an inscribed angle drawn in this semicircle, which is ADB. And the measure of the inscribed angle that drawn in a semicircle equal 90 degree. So, since AB is a diameter in the circle M, so measure of angle ADB equal 90 degree. And since AC touches the circle at A, therefore measure of angle CAB equal 90 degree. So I have here right angle and this is a right angle. So we can easily apply the Euclidean theorem. AB equal root BD time BC. This is from previous lesson, previous knowledge from Prep 2, Euclidean theorem. So I have here triangle ABC is right angle triangle at A and AD perpendicular on BC. Therefore, AB equal root square root of BD times BC. BD equal 9.6, BC at all equal 15, 9.6 plus 5.4 equals 12 centimeter. So here AB represents a diameter and I want to find the length of the radius. So the length of the radius equal 12 divided 2 equal 6 centimeter. Okay, in this part we have two well-known problems. It's very important. Well-known problem 1, if two chords intersect at a point inside the circle, if two chords intersected at one point inside a circle, then the measure of the included angle, between the two chords equal half of the sum of the two measures of two opposite arcs. So the intersected here, AEC equal half the measure of the two opposite arc AC and BD. So AB and CD are two chords in a circle intersecting at point E. Therefore, measure of the angle AEC equal half the sum of the measures of the two opposite arc AC and BD. And measure of the angle CEB equal half the two opposite arc, half the sum of the two opposite arc BC and AD. To prove this theorem, pay attention. First, I will draw AD construction. Draw AD. Since angle AEC, this angle, is an exterior angle to the triangle AED, therefore the measure of the exterior angle equal the sum of measure of the two non-adjacent interior angle. So measure angle AEC equal measure of the angle D plus measure of angle A. Measure of angle D is inscribed angle subtended by the arc AC. So measure of angle D equal half measure of angle of the arc AC. And measure of the angle A is inscribed angle by the arc BD equal half measure of the arc BD. I will take half as a common factor here equal half measure of AC plus measure of BD, and we prove here this fact. Okay. Well-known problem 2. If two rays carrying two chords in a circle are intersecting outside these two rays that contain the two chords, intersected outside at the point A. Then the measure of their intersecting angle. Where is the intersecting angle? Yes, CAE. This is the intersecting angle. Equal half of the measure of the major arc, which is CE. Subtracted from it half the measure of the minor arc, DB, in which both are included by the two sides of this angle. So if CB intersect AD at A, then measure of angle A equal half measure of the arc CE, measure of the arc CE minus measure of the arc BD, the major arc minus the minor arc. And to prove this, I will draw a construction DC. Okay, draw DC. Since that angle EDC is an exterior angle of a triangle ADC, so the measure of the angle ADC equal measure of angle A plus measure of angle ACD. Okay, so measure of angle A equal measure of angle ADC minus measure of angle ACD. Measure of the angle EDC equal half measure of the arc CE, and measure of the angle ACD equal half measure of the arc BD. I will take half as a common factor, so measure of angle A here equal half measure of the arc CE minus measure of the arc BD. Okay, let's go to the example in page 100. AB is a diameter in the circle M. Measure of the angle BMD is 50 degree. Find with proof measure of the angle ACD. Okay, he gave me information AB is a diameter, so we have an inscribed angle drawn in this semicircle, and the measure of the angle ACB is 90 degree. And he gave me the measure of the angle BMD. BMD, if I mention the center of the circle, so we have a central angle. So the measure of BMD equal 50. And we can find easily that we have an inscribed angle subtend the same arc BD, which is BCD or DCB. So what is the relation between these two angles? Yes, the measure of this angle half the measure of that angle. So let's go to the proof. Since AB is a diameter in the circle M, therefore measure of the angle ACB equal 90 degree. And since measure of the angle DCB equal half measure of the angle BMD, so measure of the angle DCB equal 25 degrees. Angle ACD divide into two angles, ACB plus BCD. So measure of the angle ACD equal 90 degree plus 25 degree equal 115 degrees. Example 2. AB is a diameter. Yes, AB diameter, so we have two semicircles. And if we have two semicircles, that means we maybe have inscribed angles. And the length of AD equal the length of BD. So we have here an isosceles triangle. Measure of the angle CAB. This angle is 35 degree. Find with proof measure of the angle CBD. These two angles together. First, we have a diameter and we have two inscribed angles. So measure of angle ACB equal measure of angle ADB equal 90 degree. So since AB is a diameter in the circle M, therefore measure of the angle ACB equal measure of the angle ADB equal 90 degree. And in triangle ABD, since the length of AD equals the length of BD, therefore I have here an isosceles triangle, and the measure of the angle ABD, this angle, equal 180 minus 90 over 2 equal 45 degree. So this angle is 45 and that angle also is 45. But we need this to find CBD. Now go to the triangle ABC. Since measure of the angle CAB equals 35 degree, that is given, and measure of the angle ACB equal 90 degree, therefore measure of the angle ABC equal 180 minus 35 plus 90 equal 55 degree. So we can now easily find the measure of the angle CBD, which is equal 45 plus 55 equal 180.